All right, welcome everyone. This is 5.3, graphing sine and cosine. Um, when you're graphing sine and cosine, we have to think about the unit circle. I know that you know the unit circle. And things to remember about the unit circle is it has the radius of 1 and it has the xy coordinate is actually cosine comma sine. So here, 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 and here, the quadrantal angles, right, of 0 and 2 pi. Here we have the angle of pi over 2. This is pi, and this is 3 pi over 2. That is what you need. The coordinates here is 1 comma 0. Here is 0 comma 1, right? Because our radius is 1. Okay, so you have to know that the radius is 1. Okay, all the way throughout this circle, right? So then this coordinate here at pi, it's negative 1 comma 0. And at 3 pi over 2, the radius or the point is 0 comma negative 1. And since it has the xy coordinate as cosine comma sine, you know those values, right? So for example, here at pi over 2, the sine value is 1 and the cosine value is 0. Okay? So that's what we will need for the unit circle. So in order for us to graph any trig function, our x-axis, right? If we may have a xy coordinate plane, our x-axis will represent the angle measures in radian form. Our y-axis is the trig values at that angle measure. Okay, so, and all the points are based off of the unit circle like what we just did. So going back to the unit circle, right? We know if our theta is our quadrantal angles like I just explained, right? At theta equals 0, at this point right here, our sine value is 0 because that's my y-axis or my y-coordinate. Pi over 2 is here. My sine value is 1. Okay, my sine value is 1. At pi, this is pi. Our sine value is 0. That's why I have a 0 right here. At 3 pi over 2, this is the angle that I'm talking about, right? And the angle is actually this angle here. This is 3 pi over 2. Okay, so this is for reference, what we're doing. And here, my y value is -1, so my sine value is -1. And at 2 pi, I'm back at the full circle at 0, right? I'm back at 0 here. And that sine value is 0. So then I have a 0 here representing the sine value. Okay, so that is actually, here is my x and my y axis. Okay, so if I go ahead and I graph this, and I copied pasted the XY chart, my x-axis again is the angle measure in radian form, and my y-axis is going to represent the sine value at that radian form, right? At that radian angle. So if I go ahead and I label my x-axis, I'm gonna skip 4 to 4 units, and that's 2 pi. Half of 2 pi is pi. Half of that is pi over 2. So here, class, I really want to emphasize that 1 unit equals pi over 2. And this is the skill, I'll go over that again, at what we just did, right? I just skipped 4 units, and I label 2 pi. Half of that is 2 units at pi, and then half of that from 0 to pi is pi over 2. Okay, so once I get this unit here, I know that each unit is going to be pi over 2 long. So pi over 2, I can label this as 2 pi over 2 or pi. I can label this as 3 pi over 2. I can label this as 4 pi over 2 or 2 pi. Okay, that's the skill that I want you guys to have. Okay, so I want to erase this and then we erase this. So at 0, right, looking at this first point here, it's 0, comma 0. So here is my graph at 0, comma 0. At pi over 2, comma 1. That point is pi over 2, 1. At pi, comma 0. Remember, what I'm doing is I'm labeling this as x, I'm labeling this as y. Okay, so at pi, comma 0, it's right here. My next point is 3 pi over 2, comma negative 1. So 3 pi over 2, comma negative 1 is right here. Right in between this. I'm going to make this a little smaller so it's not in the way. 3 pi over 2. And then my last one is 2 pi, comma 0. Okay, 2 pi, comma 0. And this, if I kind of smooth out the curve like that, that's my sine graph. Okay, and some terminology details that you guys need to know about that. A period is going one full revolution. Okay, so from 0 to 2 pi, or the width of the graph. Okay, the width of the graph would be from here to here, which would be 2 pi long, right? So that's my period. How wide, or you can think of it as how wide the shape is. This shape that it created, right? This shape here that it created, that's one sine period. Okay, it goes up, down, and then back to 0. Okay, what else you need to know is that amplitude, which is the height of the graph, from the midline, how tall is the graph? So here, my amplitude would be 1. And I know that I used midline, but I didn't define it. The midline is the middle line of the graph. It always starts off at the x-axis. Okay, so I think of it at sea level. So if you think of this as a wave, we call this the sine wave. Okay, this would be my midline here. Okay, so that would be my midline. And my midline would change if I go ahead and transform this graph. Okay, when we're graphing, we have to remember our skills that we learned how to graph, when we learned how to graph, right? And all the transformations that happens. So this is the details that you have to remember. Okay. Now we're gonna graph cosine. All right, y equals cosine. So the same thing, right? So I have my quadrantal angles at 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's my x coordinates. My cosine value, if I look at my x's at those points, it's going to be 1, 0, -1, 0, and 1, right? And we have to remember the unit circle is going to be cosine of this theta sine theta. Okay, so I just have to look at my x coordinate, which at those theta values of 0, pi over 2, pi, 3 pi over 2, and 2 pi, it's 1, 0, -1, 0, and 1. So I have my XY chart, and I'm going to go ahead and graph it again. So again, I'm going to skip 4. So fourth unit, I'm going to label that 2 pi. Okay, because that's going to be one full period of cosine. Okay, so here, halfway is pi. Halfway here, between 0 and pi, is pi over 2. So I know each unit now is pi over 2. So pi would represent 2 pi over 2. This point here would represent 3 pi over 2. And this point here would represent 4 pi over 2. I'm just adding pi over 2 every single time I move. Okay, so if you get 2 pi over 2, then that's pi. And 4 pi over 2 would represent 2 pi. I'm going to label this again, 3 pi over 2. Okay. So at 0, it's 1. At pi over 2, it's 0. At pi, it's -1. 3 pi over 2 is 0. 2 pi is 1. So welcome. And I'm going to smooth it out so it looks like a curve. Okay. So this is a full period of cosine. My amplitude will always be equal to 1. My period is 2 pi. Okay. And this is the curve of cosine. Okay, my midline would be this line here. So that's the middle of the graph, right? Midline. Okay. Okay, so now that we've graphed cosine and we've graphed sine, we're going to go ahead and talk about the general forms of sine and cosine, just sine and cosine. And we're going to learn about tangent and cotangent and all the other ones later. There's different rules for that one. So just for cosine and sine, it's going to be y equals a sine b in parentheses x minus c plus d. And remember transformations, right? What the c does and what the d does, right? It's a horizontal shift, right? Left or right, depending on what your c value is. And your d value is a vertical shift up or down. So that's what these are, right? C and D, what they represent. And the vertical shift, it actually changes the midline, right? Going back up to my cosine graph, if I move this, and I don't know if it's going to happen, but I'm going to try and move this up, it changes the midline, right? The middle of the graph. So if I move this down to, let's say, here, right? It would actually move that midline graph down. You can see that it goes down too, right? So it would actually shift my midline as well. Okay. So that's what changes the midline. My amplitude is the height of the graph. Remember, at sea level. Okay. It has to be at the midline or at sea level. How tall is my graph? Okay. So that's how you would remember it, the amplitude. And that would just be the multiplication, the constant multiplication of your sine or your cosine value. Okay, I remember when we multiply on the outside of my function, It's a vertical stretch, right? So if you're vertically stretching it, you're changing your amplitude. We're just changing our wording of what we already know. Okay, so this is actually the vertical stretch. Okay, and the period would change. Now, if we're talking about the period, going back up to my sine graph, okay, remember that it's the width of the curve, right? And if I expand it out to look like this, or if I shrink it to look like this, right? The sine function, if I make it look like that, or I make it wide like this one here, right? You're horizontally stretching it, okay? And look at where the B is in my general form. It's going to be B times x minus c, or B times x minus c in my cosine graph, right? When we're multiplying something inside my function, it represents a vertical, or not a vertical, I'm sorry, a horizontal stretch. So that's what basically a period is, right? And how we get it is, if it was the parent function, right? We know that period for cosine and sine is 2 pi units long. And if I stretch it out, or condense it in, or compress it in, it would change my period. So it's 2 pi over b. The formula is 2 pi over b, because whatever I'm going to multiply it by, it's going to change. It's going to horizontally stretch or compress my graph. So the width of it is going to change. Okay, and that formula to get it is 2 pi over b. All right. So that's what you need to know. And now that you know that, we're gonna let's graph. Okay, and we have to remember transformations. Okay, and we're gonna graph 2 periods of each and every one that we're gonna do. So let's get it. So I'm gonna graph sine of x plus 3. Okay, so there's no a value, so my amplitude is still 1. My period is still 2 pi, because there's no b value, right? My b value is 1 over 1. It's 1 because it's just 1x. Okay, plus 3, that's going to be a vertical shift up 3. This 3 would be a vertical shift up 3. Okay, so graphing 2 periods. Okay, and again, what I'm going to do is I'm going to skip 4 units, label that 2 pi. This is pi then. This is pi over 2. So then this would be 3 pi over 2, right? Because this would be 2 pi over 2. This is 3 pi over 2. This is 4 pi over 2. Okay? So I know my graph, right? And if you have to look at your notes for sine of x, regular sine of x, it's going to start off at 0. It's going to go pi over 2 comma 1, right? And this is 1. This is negative 1. Pi is at 0. 3 pi over 2 is at negative 1. 2 pi is at 0. Okay, so that's 1 period. Okay, I'm going to show you the negative version of it. So skipping 4 units again, this would be negative. This would be negative 2 pi. This would be, or skipping halfway, would be negative pi. Halfway of that half of that is pi over 2. This would be negative 3 pi over 2, right? Negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2. Okay? And now, remember our last lesson where we talked about sine being odd? What is sine of negative pi over 2? Well, the sine of negative pi over 2, if I quickly draw it on this unit circle, would be here in standard position, and it would be here, right? That would be negative pi over 2. If I go positively around to the same angle, that would be 3 pi over 2. So negative pi over 2, sine of negative pi over 2 would equal sine of 3 pi over 2, correct? That's negative 1. Sine of pi, negative pi, well, negative pi is the same thing as that here. Let me erase the pi over 2 now. That angle right here is negative pi, or it could be positive pi, right? So at positive pi is 0. Negative 3 pi over 2 is the same thing as pi over 2. So the sine of negative 3 pi over 2 will be the same thing as the sine of positive pi over 2, which would be at 1. Negative 2 pi is at 0. So here is the continuation of the graph, right? Okay. And notice that sine of the sine function is odd, because if you take the purple graph, right? If you take this one and you flip it around, it will be exactly the same as this one. If you rotate it around the origin 180 degrees, right? It will be the same as that one. That's what it makes it graphically an odd function. It's symmetrical 180 degrees about the origin. Okay, so I graphed two periods of sine, right? So then this would just be sine of x. Now my original function is sine of x plus 3. So all I'm going to do here is move this up 3. So it goes to 4, right? So I'm going to literally take this function, move it up 3 units. Okay, so it was here, right? And I go 1, 2, 3, right? So there's my graph. And if I move this guy 1, 2, 3, it should connect about the origin again, about the y-axis, right? So there are my points, and I'm gonna, since my points didn't transfer over, I'm gonna color them in. Okay, so my midline is actually changed to this line here. Okay, because I'll show you that here as well. Here was my midline at my x-axis. It goes 1, 2, 3 up. Okay, so when I ask you guys, hey, what's the midline, the equation of the midline? That's going to be y equals 3. All right. And that's my graph. Okay. So now I'm going to graph negative sine of x. And this is when knowing your transformations is key. What happens when you have a negative sign on the outside of the graph? Well, that negative here represents horizontal, oh no, a vertical reflection, right? So I know my sine function. So it's going to be actually a vertical reflection or a reflection on the x-axis. Okay. So my original function, my parent function, I'm going to label it in purple, y equals sine of x, right? I know 4 units. I'm going to graph 2 pi. Halfway between 0 and 2 pi is pi. Halfway between 0 and pi is pi over 2. So I know pi over 2, pi is 2 pi over 2. This would be 3 pi over 2. Going negative, this would be 2 pi, negative 2 pi. Halfway there would be negative pi. Halfway between that would be negative pi over 2. And this one, last one, would be negative 3 pi over 2, right? So graphing sine, 0, if I reflect 0, 0 along the y-axis, along the x-axis, I mean, it's going to still stay at 0, right? So my zeros, I know, are at 0, at pi, at 2 pi, at negative pi, and at negative 2 pi. Okay? At pi over 2, it's actually 1. Actually, you know what? Because of all the stuff, I'm going to label this as 1. Label this as negative 1. Okay, skipping 2 units, representing value of 1. So at pi over 2, it's 1 in my original parent function. But since this is negative sign, I'm going to move it down to negative. Okay, I reflected this point here along the x-axis, and I got the black point. Okay, vice versa, if I have, I'm at 3 pi over 2, my original point is at negative 1. I'm going to reflect it, reflecting it 1, 2 units. So 1, 2 units up there. Okay, up here. All right. So then positively, my graph would look like this. Right? It's just a flip version of it. So at negative pi over 2, it's actually starting off at negative 1, but when I reflect it, it goes up, and this point comes down. Okay, so finishing up the graph, 2 periods of pi, of sine of x. Okay, that's actually negative sine of x. All right, you can compare it to number 1 and see the reflection along the x-axis. Okay, now graphing sine of 2x, or 2 theta, or whatever that variable may be. I just used x. So this represents my b value, right? And that affects my period. Remember, my period formula is 2 pi over b. So now it's going to be 2 pi over 2, which is pi. So that means that every single, after the I graph one period of sine, right? It's going to be pi units long. Okay. My amplitude is still the same at 1, right? Because there's an imaginary 1 here. All right. So if I go ahead and I graph that, I'm going to move this line X. Okay. I know halfway is going to be 2 pi, right? In the original, that way it's going to be pi. That way is pi over 2. And this one is 3 pi over 2, right? Graphing my parent function of y equals sine of x. This is negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay, graphing the original function will just be like this, right? And then you guys can see that it goes like that, right? That's the original function, right? That's my parent function. But now my period is at pi. So if you think about this function here, right? This one period of pi, it has to finish out at pi, right? So it has to go up, come back down, like that. That makes sense? What is this point here then? Well, if that's pi, if one period is pi, if this is pi, halfway is pi over 2. Half of pi over 2 is actually pi over 4. Pi over 4, this would represent 2 pi over 4 or pi over 2. This would represent 3 pi, put it here, 3 pi over 4. Okay? This one would look like this, right? At that point and at that point. Okay? So if one period is pi units long, and you can see that it is pi units long because from 0, 0, from the origin to where I finished it off, right? Right at negative pi, that's one period of pi, right? So if this represents negative pi, halfway would represent pi over 2. Halfway of that would represent negative pi over 4. So pi over 4, negative pi over 4, negative 2 pi over 4, or pi over 2 here would represent negative 3 pi over 4. Okay? All right? So you can see that when we are multiplying in red, it's y equals sine of 2x. When we're multiplying on the inside, it actually shrinks. Okay? All right. My next example is cosine. And I am actually going to do this on a separate video. So be ready for that second video.